The universe of astronomy has been shaken by a revelation of unprecedented size. In a shock-filled broadcast that shook both the scientific community and the broader public, well-known astrophysicist Neil deGrasse Tyson verified that Polaris, the North Star, the heavenly pointer that has acted as a guidepost to human civilization for millennia, has blown in a supernova. What was once a beacon of permanence and dependability in the night sky is now a cosmic specter, a brutal reminder of the universe's ability to undergo sudden, devastating change. Polaris is situated about 433 light-years away in the Ursa Minor constellation. Its virtually fixed position in the night sky for centuries made it an invaluable navigational aid. While the other stars seemed to spin around it because of Earth's tilt, Polaris stood nearly still, a steadfast cosmic compass that directed travelers through oceans, deserts, and unknown lands. It also facilitated the movements of numerous animal species, serving as a heavenly landmark that navigated birds, insects, and sea animals through the night. But all that has been transformed. Tyson said weeks of abnormal brightness led up to the explosion, but no one thought Polaris would collapse completely. A supernova is one of the universe's most explosive occurrences, signaling the end of a star's life. When a star such as Polaris is near the end of its lifespan, its core exhausts nuclear fuel and collapses under the pressure of gravity. This sets off a cataclysmic release of energy, outshining entire galaxies and accelerating great masses of matter into the ambient interstellar medium. The blast that results isn't merely creating glorious light, it also sends a lethal shower of radiation, high-energy particles, and gravitational waves that can reshape the very fabric of space. The immediate consequences are mind-boggling. Mankind lost not only a star, but a pillar of both our scientific and cultural heritage. Even with satellite navigation, Polaris was a necessary backup, an analog point in an increasingly digital world. Its removal from the northern hemisphere sky is not just symbolic. For hundreds of years, sailors and travelers could count on it. Now, they are left with an empty space where Polaris once held court. The psychological and practical consequences are hard to exaggerate. But aside from human interests, Polaris's demise is a serious threat to the natural order. Many migratory animals, birds to butterflies to sea turtles, depended on its presence for orientation. Such animals co-evolved with Polaris as a constant in their internal maps. Its loss would cause large-scale disorientation, lost migratory patterns, and a chain reaction of ecological disturbances. Ecologists and biologists are already sounding an alarm, urging that species may experience heightened stress, interrupted reproduction cycles, and population decrease due to the absence of this cosmic guide. Scientifically speaking, though, the phenomenon provides a rare and precious glimpse into the center of a supernova in near real time. Unlike other supernovae that have been seen from galaxies far, far away, many hundreds of millions or even billions of light-years removed, Polaris is near. Its nearness makes it possible for astronomers to gather much more precise information than ever before. Telescopes worldwide, and in space, have pointed themselves at the remnants of the dying star. They're taking readings of light fluctuations, radiation spectra, neutrino outputs, and gravitational wave perturbations. This information may hone, or even redo, our existing theories of star death and rebirth. However, what is most unsettling about this supernova is that it was not symmetrical. Tyson disclosed that Polaris's detonation was not symmetrical. Contrary to textbook supernovae, which are quite predictable in their behaviors, Polaris exhibited anomalies right from the beginning. A sudden burst in neutrino emissions was captured mere seconds before the light from the explosion hit Earth. These phantom particles, which pass through matter without obstruction, are typically the harbinger of a star's demise. But the spike was singular, much stronger than any other seen in past supernova phenomena. Even more disastrous were the ensuing gamma-ray bursts. Erratic, powerful, and beyond known patterns of behavior, they indicate that Polaris did not collapse into the neutron star anticipated. Rather, there's increasing evidence that it could have directly collapsed into a black hole. If true, Polaris would be the nearest black hole to Earth, a proximity that can have long-term repercussions in our local part of space. Though 433 light-years is still safe distance by most estimates, black holes exert gravitational pull in a manner we're still yet to fully understand. Their existence has the potential to warp spacetime, change the trajectories of objects in proximity, and possibly initiate events over astronomical scales. Fueling intrigue further, astronomers have found mysterious pulsating signals coming from the coordinates where Polaris previously glowed. These signals, pulsating in regular intervals and rising in frequency, are unprecedented in something previously documented. Some scientists propose that they might come from a newly born magnetar, an ultradense neutron star with a magnetic field 1 trillion times stronger than Earth's. Others propose that they could be from churning gas clouds interacting with the supernova's shockwave. But a minority of vocal scientists are beginning to ponder the unthinkable. What if these signals are not of natural origin? Tyson personally didn't openly support this radical concept, but he recognized the anomalies. He characterized the signals as mechanically rhythmic, suggesting that their man-made looks couldn't be simply ruled out. Was the explosion of Polaris possibly caused, or tampered with, by a foreign entity? Does it make any sense that a higher intelligence has meddled in the life cycle of one of our key stars? Mainstream science is not yet convinced, but the fact that such questions are being posed in earnest indicates the strange character of the data coming out of this event. Meanwhile, Earth already feels the tremors. Detectors on the ground picked up an increase in cosmic rays, high-energy particles that can penetrate the Earth's atmosphere. While our magnetic field protects us from most of this radiation, the number of incoming particles is greater than usual. Communication has been disrupted for some satellites temporarily. There are worries that a sustained bombardment might not only impact orbital infrastructure, but electronics, power grids, and even human health, especially for astronauts on the International Space Station or upcoming deep space missions. More unsettling is the long-term effect of such radiation. Some studies suggest that increased exposure to cosmic rays could lead to genetic mutations in living organisms, potentially affecting ecosystems in ways we're only beginning to understand. Polaris's death, therefore, may not just impact our psychological and astronomical outlook, it may also touch life on Earth at a biological level. Culturally, the loss is profound. Polaris has been a star, but more than that, it has been a symbol entwined within mythologies, religions, and philosophies globally. It was considered by ancient cultures ranging from the Greeks to the Native Americans as the axis of the heavens, the cosmic spindle upon which the world rotated. Its elimination removes not just a physical light in the sky, but a spiritual and historic anchor as well. We are now confronted with the disquieting knowledge that even the seemingly immortal can perish. And then there's the question of timing. It has been noted that the death of Polaris coincides rather ominously with humanity's first serious forays into interstellar space travel. As we start launching probes into outer space, creating lunar settlements, and talking about missions to Mars and beyond, the universe reminds us of its awesome and uncaring might. It's as if the universe has given a blunt warning: move forward, but know your place. Tyson suggested as much when he announced his retirement, saying, "We have always looked up to Polaris. Now we must look inward and question what we thought we understood." This has sparked philosophical discussions among academics and public circles alike. Are we really prepared to meet the inner realities of the cosmos? Have we overestimated our readiness to face the chaos outside our world? The passing away of Polaris could be the first real check on humanity's capability for adjustment, not only technologically, but emotionally and mentally, on a dynamic and unforeseeable universe. Already, scientists are setting their sights on a new era in astrophysics. Space-based telescopes such as the James Webb and Hubble have transitioned to observe the expanding cloud of wreckage where Polaris previously was. Ground-based arrays are triangulating the pulsating radio signals, attempting to see whether their patterns decode information in unknown patterns. Neutrino telescopes embedded in Antarctic ice are recording subatomic messages from distant space, and gravitational wave detectors search for the faint tremors Polaris's demise might have passed on to the cosmic cloth. But for all our equipment and information, the enigma grows stronger. Polaris is gone, but its shadow remains, not only in radio waves or particles, but within the collective psyche of a species once comforted by its presence. The globe holds its breath as scientists labor day and night, scrutinizing data, debating ideas, and struggling with answers that could redefine the entire discipline of astrophysics. Yet, beneath the fear and awe is a profounder truth. Out of the ruins of one star will rise new stars, in time. The supernova has put heavy elements, iron, carbon, oxygen, into space, enriching the galactic plasma. These will plant future worlds, as identical stellar catastrophes billions of years in the past once planted ours. The demise of Polaris is not only loss, but regeneration, a reminder of the cycle of cosmic birth and death. But as we stand under a sky that has lost its most recognized light, it is difficult not to feel exposed. The constellations appear different. The night appears more profound. The cosmic chart we knew has forever been altered. And in the dark, a question now shines brighter than any star: what happens next? Whatever it is, it's only just starting.